Hi everyone, welcome back and welcome to chapter 2 in our course. Today we're going to go over 2.1, which is graphs, stem and leaf, line graphs, and bar graphs. So let's get started. So let's talk a little bit more about descriptive statistics before. So the goal of this chapter is to study how to display our data. So this is an anecdote, okay? You don't have to know this, but I don't know if you guys are familiar with Florence Nightingale. She is actually considered, she's like a famous nurse, and she's considered the mother of nursing. Well, did you know she's also considered like the founder of statistics because, let's say, one time she was studying at a hospital. She was helping out in a hospital, and she noticed that they were really dirty, like the conditions were really dirty and people were dying. And so she took data together, and she also started to clean up everything, and then she started recording the amount of deaths. She presented it to the king at that time, and since then they started to make the hospitals more clean because she used statistics. She didn't know it was statistics, but she took data and demonstrated it to somebody and actually made a change. So really interesting story. So anyways, that's that. So we're going to go over specific graphs today. All right, so this guy is a stem and leaf graph. So it's also, so this is basically a good choice when you have like a small data set. So we have what's called a stem and a leaf. So let's say here you have the number 33. The leaf is the 3 and the stem is the first 3, the tens place. So this here, this weird one where it says 4299, what this actually represents are the numbers 42, 49, and 49. Okay, so let's look at the next one. So this is stem is 5 and the leaf is 355. So that would be the numbers 53, 55, and 55. So can you tell me, and I know it's going to be silly because I'm asking you to talk out loud to a video, but can you tell me or yourself what this next row would be? So you can pause it here and tell me, and then I'll tell you. Okay, so this row would be the numbers 61 represents 63, 67, 68, 68, 69, and 69. So it consists of 1, 2, 3, 4, 5, 6, 7 numbers, okay? So it's, you see how it's like easier to organize the data in this way because you can have, you can notice right here, oh, there's a lot of 90s. Oh, there's only one 100. There's a couple of 80s. So the most data occurs in the 90s range and in the 60s range. So that's an example. So I think we have another one. So here, so to talk about a little bit more about the stem and leaf. So 23 will have stem 2 and leaf 3. The number 432 has, the leaf is just the last number on the right. So leaf is 2 and the stem is 43. Here, if you have the number 5,432, the leaf would still be 2, but the stem is 543. Okay, so this decimal, for instance, would have stem 9, and then the leaf would be 3, so 9.3. So the division would be right here. Okay, so how do we create this graph? We write the stems in a vertical line from smallest to largest, and then you can draw a vertical line and then write the leaves in increasing order next to their stem. So let's do an example. Course, where would we be without super fun examples? Okay, so let's see here. We have Susan's pre-calculus class. Scores for the first exam were as follows, and then see how it goes from smallest to largest. Okay, so let's pretend you can't see this right here, and can you create a stem and leaf graph with this data? Okay, so how would I do that? Well, let's just let's use it, I guess, so you can see. So 33 is expressed as here, 33. 42 is right here, 4 and 2. So see here, 49, there's 2 of them, so it's 4, 9, 4, 9. 53 here, 53. You see what I'm saying? 55 is 5, 5, 5, 5. And notice all the 60s, right? You have 61, 37, 68, 68, 69, 69. See, they're right here. 61, 63, 67, 68, 68, 69, 69, right? All the 70s, all the 80s, and then finally, and all the 90s, and then 100, okay? So that's basically, that's it for those graphs. It's really, really very simple. But let's look at another example. So what does this mean? That most of the scores, if you want to analyze this data, we're talking about test scores. So most of the scores are 60s, 70s, 80s, and 90s. Okay, so 8 of the 31 scores were in the 90s or 100, so that's pretty good. That's a high amount of A's. You know, like, that's a pretty good amount. All right, let's continue. So let's see here. The data and the distances from a home to local supermarkets. So let's create a STEM plot using the following data: 1.1, 1.5, 2.3, 2.7, 3.2, 3.3, 3.3. So basically all of these numbers, right? Can you create a stem and leaf plot with that? So, so again, this is the time where you pause the video, pause it, like seriously. I know it sounds crazy, but just humor me. Please just do me a solid. Just pause it right here. Try this example on your own. And remember that right now is the time to be wrong. Like, now is the time to make mistakes. Now is the time to put whatever on the paper, because this is like the learning process, okay? So if people were not wrong, they would not learn. So, you know, anyways. So yeah, so I'll give you a second to do that. Okay, so now that you're done pausing it and you've tried it and you have it on your paper, let's see how close you were, or if you were completely close. Boom. Okay, so we have here 1.1, 1.5, 2.3, 2.5, 2.7, 3.2, 3.3, 3. So here's all the data. Okay, so the only thing is that between 7 and 12, there is no data here. So if you had just put a blank space and wrote 12, 3 like that, you would still be correct. It's fine. It's fine. You know, they just put in the extra numbers just to show that there's nothing for them, and then so that it could be consistent, but in this case, it's fine. So 12.3 looks like it might be an outlier. I don't know if I haven't defined an outlier, but it's a data point that's out really far from most of the rest of the data. Okay, so, and we're going to formally define this later. Okay, so at 3 or 4 kilometers is where most of the stores are. So by looking at this graph, you can say that, okay? All right, let's continue. So that is it for stem and leaf. And now line graphs. So what's a line graph? Okay, so a line graph here, let's talk about this. So in a survey, 40 mothers were asked how many times per week a teenager must be reminded to do his or her chores. So here's the results. So let me just break this down for you, because it's really important that you understand when it says frequency and you know, that kind of thing. So here it says the number of times the teenager is reminded. So this frequency of 2 says 2 out of 40 mothers say, hey, I don't have to remind my teenager to do chores at all. These are the lucky ones, right? These are the lucky moms. Here, 5 of the moms said that I need to remind my teenager to do chores at least once a week. Okay, so 5 of the moms, the frequency of data values is 5 here. So here, 8 moms said that they needed to remind the teenager twice a week. Okay, here, 14 moms out of the 40 needed to remind their kid 3 times a week. And then here you have 7 moms that need to remind their teenager 4 times a week. And then here are the unlucky 4 of the moms needed to remind the teenager 5 times a week to do their chores. So that's pretty, yep. Sorry, guys. Okay, so now how do you do the graph? So this will be our X and this will be our Y values, okay? So let's see here, you have number of times teenager is reminded versus frequency, right? So you have here 0 when frequencies to this value is 0 and so forth. So that's the point right here, 0, 2. Then you have here when the teenager is reminded once, that five mothers said they needed to remind their teenager one time. So that means for 1 for the number of times, and then 5 here for the frequency. So you see here. So 2 corresponds to 8, 3 corresponds to 14, and then you have here 4 corresponds to 7, and then 5 corresponds to 4. So you would first plot the points, and then the line part is literally, yes, it's exactly what you think it is. You just connect the dots with the straight line. It's really not that challenging. And boom, that's your line graph, okay? All right, let's continue. So bar graphs. So what are bar graphs? Bar graphs are basically just that. It's a graph that consists of bars, okay? The only difference is that the bars between this and a histogram, they're separated from each other. Histogram we're gonna get into in a little bit. So the bars are rectangle, or they can be like 3-dimensional, and then they can be vertical or they can be horizontal. So let's see here. This is an old example, 2011. So 2011, Facebook had over 146 million users in the US. So this table shows 3 age groups: the number of users in each age group and the proportion of users in each group. So let's construct a bar graph using this data. Okay, so we have here what? From 13 to 25, there's 65 million, about 65 million, right? From 26 to 44, there's about 53 million, and then 45 to 64, about 27 million. And here are the proportions: 45% out of the total, 36% out of the total, 19%. Okay, so for funsies, how did they get this 45%? Okay, so if you're curious, so we have here, you add the total number, so, you know, the total number of people interviewed, and then you take this one and divide it by that total. So I'm thinking this is like about over 146 million. So 65 over that would give you about 45%. Yeah, more or less. Okay, so what else can I say? Okay, so now that we've done this, we have our proportion and we have our age groups and we have the users, we can create a bar graph that shows us this data. So if I was to let the x-axis be, or in other words, the horizontal axis consist of these 3 age groups, I can label it this way. I can label this one 13 to 25, this one 26 to 44, and this one 45 to 64. And then up here, I could put either the active number of users or the proportion. Sometimes the proportion is easier because you can just say, oh, 45% of them use this, you know, out of the total. So see here, 45%, 36%, see they're kind of aligned here. And then this one is 19% right below the 20, okay? All right, so then I'm going to show you some examples of graphs now. All right, so we have the SAD, the standard American diet. SAD. That's funny. I thought it was funny. So this is obviously like a chart made to question, you know, what Americans eat. So processed foods consist of 55%. Animal products consist of 30%. See, vegetables and whole grains are very tiny. So this is kind of like a warning, hey, you guys need to change your diet. That's what whoever wrote this, right? I don't know where they use this or what have you, but see how this is a good example of how a graph can kind of elicit a response, or it makes you think, or it makes you, wow, I didn't know that, or, you know, possibly make a choice, you know. All right, so let's see here. Acid load to kidneys. Wow. So when you eat these things, it adds, I guess, acid to kidneys. And then here, it doesn't really. Bread, rice, beans, fruit, and veggies are more alkaline. So, oh, that's interesting. And then, so this is a bar graph, but like going in positive and the negative direction. Okay, and then this one, remember, it was Pareto. So it's a bar graph, but in order from least to greatest. So you have increase in after-tax income by income group. So this is a really old study, right? So they increased by 16%, 23%, and so on. And the highest one was 281% increase in after-tax income. All right, and that's it for 2.1. Your homework is 1 through 9 odd from the practice, and just, I guess I'll see you on our next session, and please feel free to email me if you have any questions. All right, see you on the next video.